So hello and welcome to the next training session of the Planets project. We have had quite a couple of trainings on SSbD already, and now we are diving into safety dimension. And I would like to thank all the people who have contributed to this one. So these were the colleagues from CUSA Lab, Shimon and Anita. BSF, we have a couple of people participating and contributing to this session, Aisha, James and Philip. Also thanks to CEA colleagues, Cecile, Josephine, Nienke, Marie, to Susan and Neeraj from TNO, to Panima from Radboud University, Beatrice, as always, supporting us with the interactive tools from BNN, and Mario, Sabine, Norbert, and myself are going to be helping here from the plus side. So what are we going to do today? After my short introduction, we will dive into the basics of the safety dimension, really starting at risk with Paracelsus law and all this kind of background. Then we are, as always, going to have an interactive element in there on material safety data sheets. Then Susan is going to take us into the SIS database and into grouping and read across to understand a bit the background of that one. And then James from BSF is going to be talking about regulatory toxicology and current practice in industry, how this is performed. And then we will wrap this up, and this will be just the first of a series of sessions. So we are starting from the basics, from the beginning. Of course, we are going to be developing this further into higher tier level assessment as they are needed. So next time, in a week from now, actually, we're going to be talking about intermediate assessments at tier 2 level, relevant for SSbD from the safety dimension. And since I was mentioning SSbD, just a very short reminder, we had seen this slide already a couple of times. We are in our project implementing SSbD in industrial value chains. So we need to integrate knowledge that we regain from the safety dimension with knowledge we gain from the sustainability dimension. There are some quite relevant differences in how these assessments operate with design. So also functional performance, functionality aspects need to somehow evaluate it in trade-off manner against each other. This is SSbD. How we conduct, we have also introduced before in Planets. We have our scoping in this green area where we kind of overview the entire process, depict the value chains that we operate on, and also identify the motivation for a redesign by prioritizing. There is a training session which you can pick up in our Zenodo community or YouTube channel, and basically from our homepage as well. Then we go into the SSbD planning and conduct the assessments at different tier levels, starting with the simplified, then into the intermediate, and later on the full kind of assessment extent. A very short thing which we also saw already once, not relevant, but it's in a different design now. So there was, in the former framework of SSbD, these 5 different steps, but 3 of them were actually adhering to the safety dimension. So we are now not differentiating this step so much anymore. But what is relevant, and I wanted to show this once again, there is this kind of sequential conduct, and here down where we are kind of first planning in the scoping phase, then identifying alternatives, and then assess them functionality against safety and sustainability dimension. But following this general workflow, we would then in the end end up with aspects with different information content, different certainty levels as well, from the safety area, from sustainability dimension to be evaluated against performance characteristics, and to kind of come to a conclusion in order to be filtering out the most promising candidate, whether it's a kind of an improvement or maybe not something to go forward with. And these are these 2 important phases in this process. So talking about data on the safety dimension now, in this tier 2 level, I mean on the tier 1 level, we have a very qualitative questionnaire-based approach in our project, and many other projects have do this alike. At the tier 2 level, so in the intermediate assessment, we are already starting to get some values, some quantitative values, but mainly getting them from database screening, for example, from in silico, in chemical experiments or in silico modeling, and then at the tier 3 level, hazard assessment and exposure assessment determination are going to be conducted. What we talk about today is safety, which is actually the inverse of risk, and risk is equal to hazard and exposure. And I mean, at least some of our questions were pointing a little bit into this direction. So for example, if you go to the road now and maybe not stay within this project, but into the street, and you want to make clear what risk is, then it could be a good idea to, for example, come up with this comparison, a shark and a bike. So I'm living in Salzburg, and although the shark is a very, very hazardous fish, yeah, I'm not going to be dying from a fish. It could be rather probable that I'm hit by a bike and might hit my head or something and would die from a bike accident, although a bike is not a very hazardous instrument. So there is no life without risk, and by minimizing either hazardness or exposure, so one of them also, we can already minimize risk. Another example could be, well, this is quite hazardous, such a rock, but there is no risk at all. Just if somebody stands there on a risk, on a kind of rock like that, which is very, very exposed, then there is a certain risk that for whatever reason, maybe a very strong wind blowing up, this person might fall down. So there is this risk, and we should never forget when we talk about hazardness in assays, for example, in SSbD, that it really depends on the exposure. So therefore, safety has always to be discussed in relation to both of these factors. Another important point is that there is acute exposure, like here, for example, in this example, and immediate and rapid effects might occur, but there is also chronic exposure. And this is much, much harder to look at and to model in the models that we have available. So we know that we have to go more and more from animal experimentation into, for example, cellular assessments. And there is a big need for models that are also depicting this kind of long-term view. So chronic exposure models are, for example, like in this example with smoking, is something that we have a very, very big problem to model in vitro systems. And then there is also the issue of correlation versus causality. A nice example may be that the visibility or the kind of notability of storks correlates with the newborn baby counts. And you see this very nicely on these baby counts and storks which were seen in this left-hand graphic. But I guess we agree, all of us, that there is no real causality in this correlation. However, there are some correlations where there is causality, and what is in the back of that, for example, is then the mechanism. There must be a mechanistic proof of that there is really a substance or a key event that leads to this outcome, adverse outcome. And one of many examples could be, for example, here the lung cancer mortality rates by cigarette smoking status for men and women. And you see here the never smokers versus the current smokers, there is a higher risk. So I guess we are clear with what risk is, and this is now a nice picture from Paracelsus. He was the very first one mentioning that there is no kind of risk, no venom, if there is no knowledge about the dose. So we always have to relate the hazardness to doses. Yeah, there is a connection between hazard potential via the dose to the risk. And many factors may influence that. It depends on which route of administration we are kind of exposed to, whether via the skin, the inhalation, the injection, or the ingestion mode. I mean, there's a big body surfaces. The lung surface is like a tennis court in people, versus the skin is a very short area, of course, a very small area. So the inhalation route is a quite prominent route for that reason, for example. Yeah, the way of exposure, the duration of the exposure, and I have mentioned already the acute versus the chronic exposure. And there are very important issues in terms of the resulting concentration at the organ that is affected. And if we typically look into in vitro assays, we typically look at an organ level or at a kind of cellular level that is a kind of a proxy for an organ exposure. There we have to be really very considerate about the concentration and the dose that we really see. So the interaction with other toxic compounds, interactions may be quite relevant. Environmental conditions, heat might then also alter the situation, physical conditions of patients or of since, I mean, we have to think of course, of the human cohort, and we are much more diverse than the mouse cohorts or the rat cohorts in a kind of certified environment, of course. So there are also preconditioned situations. People have pre-existing conditions, for example, maybe a pregnant woman or a child or an elderly person. These are examples, or somebody that has just undergone a kind of inflammatory disease, for example, and these, of course, have different thresholds then in the end. Therefore, hazardness is not linearly translating into the risk of a certain population ratio. Age, sex, health conditions are implementing, in summary. Good. Yeah, I mentioned Paracelsus already. He's, by the way, buried in Salzburg. And this is a typical curve. And we see here the mortality rate, and here are the dose. We can talk about the lethal dose if the mortality is here on the y-axis, but we can talk about effective concentrations, and a value is a typical value is also effective concentration 50, which means 50% of the population is affected by this, which is the fact that you observe, and then you can have something else on the y-axis, for example, but this is a typical term. So the dose is relevant. And there are also these Lowell's and Noel's or EC20 values that, for example, then are predictive, not predictive, but descriptive values for a substance. Some more vocabulary. So we have the dose. I mentioned it already a couple of times, the amount of a substance that was delivered. The concentration is the concentration of a substance at a particular target. So this could be at a tissue level, at the organ level, but also on a cellular level in an assay, for example, or in an environmental compartment. If we not look at humans, for example, if we look at animal species out there, like Daphnia, for example, is a typical reporter system for the ecotoxicological area. Yeah, the lethal dose, 50 or lethal concentration, was mentioned already, and this is basically defined as which leads to the death of 50% of the investigated individuals, or the effective concentration 50, which I have mentioned. And here there is the NOAC or the LOAC, Noel, and the LOAC and the Lowell, with the lowest concentrations or levels that do not show yet, or that just start to show an effect. A little practice in that. Here we have got a substance, or two substances, and we observe now here the mortality and the dose. So the more of the substance from the left to the right I get, the more mortality I observe. There is a substance A, or substance 1 in green, generating a lower EC50 value, and there is a substance 2 in blue, generating a higher EC50. Which one is the more dangerous one? Let's go to the Menti. Yeah, so it looks as most people very correctly identified substance 1 with the lower EC50 value as the more dangerous one. So I need less of the substance in order to have the same effect, which is the truth. And everybody was sure how to answer this one. So I guess we can go to the next example. And I guess we would just see. So we see here now, again, two substances that obviously have the same EC50 value. So same concentration of effectiveness here. But obviously, the blue one starts to become a little bit more showing an effect than the green one. So which one is the more dangerous one? It looks a little bit different than before. So there are different views, obviously. There is one respondent which says substance 1, which is the green one. Although it starts later to show an effect, it has the same EC50 value, but it generates a more prominent effect earlier, really loading kind of killing all the entire population. And then there is quite a number of people considering the substance 2 the more dangerous one that starts earlier. That's the blue one. Then some people have not really decided, and then there are a couple of depends on the context. And then I would like to know, I mean, maybe somebody wants to give an example of what this context could be. So we have 2 times the dose, no, 3 times, depends on the dose / concentration used, exposure duration, so the time aspect. Is this substance in kids' toys or tires, which relates a little bit to the exposure? It depends on the exposure. So the time aspect is a very prominent one. Then there is a question with what parameters you consider. This maybe would require further explanation. Maybe somebody wants to chip in here. Who wrote that? Okay, this is also a nice one down here on the right corner. A general representation of people. So this goes a little bit into the variety of different people, into eventually pre-existing conditions. Some people, the effect is more powerful than for others. And this impacts, of course, a kind of population-derived sigmoidal curve that we see here. And it depends on the mode of introduction into the body. So then a number of different circumstances which make sure that this can be seen from both sides. I guess there is not a truth for this question that this holds true for every and each case. So as we did see this sigmoidal curve, just a very few remarks on that. Important is also this hill slope, so the steepness of the curve. And sigmoidal curves are the typical thing that we observe in risk assessment and in hazard characterization. So relevant parameters are this top level, the bottom level, the EC50, and the hill slope. And these are the descriptive parameters that feed this analytical solution of such a curve, because in the end, then we feed, of course, calculation sheets. And this is not an easy task. Excel does not have a preset solution for that, but this is the hill slope, basically the general description of such a kind of sigmoidal curve. And with this, you can solve actually these problems and smooth your curve, for example, on the data that you generate by analysis. Good, and with this, I would like to give over now for exposure, terminology and background to Josephine.
Thank you very much, Martin. Let me know when you see my screen.
Okay, thank you.
It's okay.
You see it.
Okay, so I have seen in the answer in the multi that someone has answered to the last question. It depends on the mode of penetration of the chemical. So let's talk about the three main route of exposure, which could be inhalation, ingestion, and cutaneous. I will not talk about injection here because we do not foresee that in usual chemical settings, you could be able to inject chemicals in your own vein. And then the chemical product will be able to pass through the blood and be distributed to the different organs. So we can ask ourselves, do we really need a sound management of chemicals? You have to know these few numbers from the European Union. So there is approximately 100,000 chemicals on the market. And among these chemicals, only 500 have been extensively characterized regarding their hazard and exposure, while more than 70,000 are poorly characterized for hazard and exposure. So that's also why we are working on chemical safety. and how to mitigate this risk. So I think that one of the main things to know, and you have to be aware of that, is that we are, all of us, really used to assess risk and to make decisions based on our assessment. For example, this morning, you may have left your home to go to your facility. And if you are, for example, like myself, bicycle to work, and in France, the first things you have done is maybe to put an helmet on your head. If you are from Utrecht, for example, we have seen that due to a huge control level, it's not as necessary as it is in France. And if you have, if you drove to your work facilities, I am quite sure that the first things you have done is to fasten your seat belt. And in each case, you have seen a hazardous situation which you are exposed of. You have assessed the risk and you made a decision to mitigate this risk based on personal protective equipment, based on control level, based on other things. So this could be summarized, not summarized, but extended in the 9 general prevention principles to mitigate the risk. The first and the most effective way is to avoid the risk. Then is to evaluate the unavoidable ones. Then is to combat risk at source. 4, to adapt work to the individual instead of the other way around. 5, to adapt the place of work to technical progress. 6, to replace dangerous by non-dangerous or less dangerous. 7, to use collective protective equipment over individual. 8, to develop an adequate prevention policy. And 9, to give appropriate training and instruction to employees. We can summarize simplified this 9 general prevention with the stop principle. If you have to remind one thing as industrial is stop. S for substitution, T for technical, O for organizational, and last and least, P for personal. But I am quite sure that in a lot of situations, you are using personal protective equipment. I have put some information about skin and respiratory protection. So regarding the chemicals, there is 3 main category of gloves against chemical according to a standard, depending on the breakout time of certain chemicals. So you can have a look at this standard if you want to have more information. And regarding the inhalation, you have 2 types of respirator. First, the tight-fitting one, when your lung will do the job to inhale and exhale the air, but you will have kind of filter on the respiratory protection. And another one where you will be assisted by kind of ventilators that will help you to provide fresh air. And now that we have seen that safety is the opposite of risk, that risk is a combination of hazard and exposure, how can we slightly assess the hazard and how the chemicals can enter your body and slightly how to mitigate this, or the main principle to mitigate this? Let's see how to understand the hazard assessment with in particular with the current regulatory and the document we can find on the material safety datasheet. So first, you have to know that there is a globally harmonized system which apply all over the world with rules for classifying the hazard of chemical product and rules of how to communicate them, such as the format from the material safety datasheet and the content for label. And this has been transposed in Europe at the European level by the Classification, Labeling and Packaging CLP regulation. And how does it work? First, you have the visualization of the hazard thanks to a pictogram, which are let's say, ranked into 3 categories: physical hazard, health hazard, and environmental hazard. I am quite sure that as we are a lot of chemists here, you already are aware of how this pictogram works and what they mean. But when it comes to the hazard statement, there are kind of a code, which is a signification. So the code is H, number 1, number 2, number 3. The first number will help you to identify the type of hazard. So 2 for the physical hazard, 3 for the health hazard, and 4 for the environmental one. And if we dig a little bit more in the health hazard, you will have then the signification of the second number. 0 means ingestion, 1 cutaneous or eye contact, 3 inhalation, while 4, 5, and 6 means respectively mutagenic, carcinogenic, and reprotoxic. And 7 is for specific targeted organs. Let's talk about the last number. If it's a 0, usually it means that it's lethal. For example, H330 means that it's lethal by inhalation, 300 lethal by ingestion, 310 lethal by cutaneous contact. And you can find all of this information, as I said previously, in the safety data sheet, which is composed of 16 mandatory headings. And if you are not used to look into safety data sheet, I would recommend you to focus at first on the section 2 about hazard identification, section 3 about composition information and on ingredients, 8 about exposure control and personal protection, and 9 physical and chemical properties. This information could be found also on the label of chemicals. So you will find the pictogram for the visualization. It gives you an information, but it's not enough to assess the risk or to assess the hazard. You have then to go deep on the sentences. It could be the same for preparation and substances. So when you are selecting a new chemicals, the idea will be to look both to the pictogram, but not to forget the hazard statements. And you can look into the label or the MSDS. And we will go on an exercise in the mural prepared by Beatrice. The idea is you are looking for high temperature paint. We will give you some information on the MSDS on the mural, and you will have to choose one product and to justify why you have chosen this one.
Welcome back. Since we are all back, I would like to give now the word to the moderators or the reporters from the different discussions in the breakouts. I know that Cecile is going to summarize for room 2, and who is it for room 1?
It's me as well.
Okay, shall I display the slide or you will?
Maybe I will just a mural in 1 minute to report what we have decided in the group 1. So in the group 1, we have said that Rust-Oleum will not be possible. It's kind of a no-go because of the carcinogenic sentence. So we will not choose this one for sure. We have a preference for the chameleon because it seems to be more safer for human, even if it's not safe for ecosystem. Apparently, we will choose this one, but the electrolyte seems to be not a spray paint, but another type of application. So we would not cancel this one now, and we would like to go further to have the exposure assessment as well, to see if it's easier to mitigate the risk with the electrolab than with the chameleon. And of course, we have said that we should at some point look at the functional properties of this paint to be sure that the one is not better than the other one. Cécile, do you want to conclude on your discussions?
Yes. So it's quite interesting because we don't reach on the same with the same preference. So finally, the orientation is more on the Rust-Oleum on this side, because this the point regarding the physical hazard for the two others could be more exposing than the Rust-Oleum, but more on the during the use and the risk of flammability. So yeah, we in our groups we are put the Rust-Oleum first, and do not consider it for the moment the two others.
Thank you, Cécile. So it seems that based on our discussion, what we have seen and how we look at things, we can have different decisions. So that's why it's really important to make the decision at a multidisciplinary team with all the value chain, all the experts, and so on. So to conclude with the presentation, we have made the exercise regarding only the health hazards to assess and each of these chemical, and we have seen that with our the tools that we use at CEA, at least, Rust-Oleum is the most hazardous chemical with a score of 1,400. The total is the maximum that could be reached is 2,300, while electrolube and chameleon are in the same range and in the same what we call band of product, and therefore, if we focus only on the health hazard, we could keep chameleon or electrolube, and then we will have to assess the exposure and other parameters to make an enlightened decision. And that's it for my side. I will leave the floor to Suzanne or Martin if you want to.
Yeah, maybe a few words on the tool that you mentioned from CEA. There is a tool that you obviously employ coming up with these values and these colors then in the end. Maybe you want to say a few words on that?
Yeah, it's a control bonding tool, but I think, stop me if I am making a mistake, but Cécile, you will present it in the session 2 next week? Yes, no?
No, in session 3.
In session 3. So a bit of a teaser then, just to wait until session 3. The tool we use at CEA is named Quarks, but whatever the name is, there is other tool at the same kind, like Stoffen Manager or things like that. The idea is it's a control bonding tool. So the main idea is that it assigned a score or a color band to a hazard class or an exposure situation. And it's help to make a decision regarding the chemical risk assessment. That's a way of performing the assessment that is very usual for chemical health safety engineer, and that's how we use it.
So actually, I was gonna tell about databases. So yeah, except for the next to the MSDS, so the material safety data sheet, you can also look up, why is this taking so long? You can also look up substances. There it is. For you, it might still take a few seconds. You can look up hazardous substances in databases. Very well known is PubChem. We have another one called Substance Information System at TNO, which gets information from various other databases like PubChem. And here is the link to it. You can log in. It's free of charge to use it. And here I have a screenshot. I typed in acetone. It's one of the material or the ingredients of the paints in the previous exercise. You can also put in a CAS number, anything, and then it pops up, and sometimes you have more than one. Now it shows, right? So sometimes you have more than one substance if you start typing. But now if you click on acetone, you can see there's compound information, health effects, applications, and exposures you can have a look at. So here you have some compound information, and there's more than this. It's just a screenshot. You can also see all the synonyms. So this is why you sometimes see more than one chemical when you type it in. One thing I wanted to show you is that you can also look at these H phrases. It's not working again. Yeah, there it is. And these pictograms that you showed in our last exercise. So this is for acetone, and you look into the tab health effects. So you can see these pictograms. You can also look into what is what. And it also gives you a hazard band. So this is the hazard band from another control banding tool than the one that the French that CEA is going to show. But you also see classifications at the bottom. We have the classifications that are harmonized, so done by ECHA, but also the self-classifications. But for acetone, there's only here the harmonized ones, and then you can see it's flammable and the H phrases that come along with that. So next slide, please. So next to only hazardous or H phrases, you can also look at human limit values. Well, for example, occupational human limit values or occupational exposure levels, and you have them for 8 hours. So that's chronic, but you also have them for short term. So the STEL, they call that short-term exposure levels. Please move on. This information you can also look up in the SIS system. It's under the compound information when you scroll all the way down, and here you see they differ from different country. And sometimes we do have EU ones, but some countries want to be stricter, so they might divert from that. So you can look this up, and these are actually exposure limits, which are the exposure limits you should not exceed at the workplace. So you move on, please. So that's a little bit about the database. There's much more in it, but I'm not going to explain it at this moment because I wanted to connect it to what we have seen so far. Another thing you can do is grouping and read across. And that's this slide. So we have, for example, OECD, but there's also a document from ECHA, the RAF document. I didn't put this on the slide because I'm going to tell you a little about this guidance from OECD. It has a stepwise approach, which is shown on the next slide, which you can follow, which is called the analog approach. And it starts very, well, general with the problem formulation, of course, and then determining the type and number of data gaps you have on a certain chemical. So what you basically try to do is you have a chemical for which you don't have any information on the hazard, or you're missing certain hazard information, and you try to find a chemical which is similar from which you can use this data. So you can then identify the gaps and also have a look, can I address these data gaps with existing methods like QSARs, IATAs, or other ways that have been defined. A defined approach, for example, there's one for skin sensitization. It starts with in vitro assays, and yeah, you can follow this approach to fill in these data gaps. But if you don't succeed, you go to the next step, which is on this slide. You can check, well, is this chemical by any chance a part of an already existing chemical category? which I can use. If not, so for example, if you're talking about, for example, what is it called in English? BAH, so poly, oh, sorry. Well, you have some of the substances for which we do have a category approach, and you can look them up. In the guidance document of OECD, you can also find the examples and also find the way to look these existing categories up, and you can follow this approach. But if it's not there, then you can look for structurally similar materials or contextually similar materials, but also look at properties relevant for the endpoints that you have this data gap for, or similarities in metabolic pathways of the chemicals. So this is what you can use to find a similar substance for which you can use read across. And then, of course, you have to gather the data for these analogs. That's step 4. So you gather all this data in the next slide. Yeah, so this is in the annex, you have this data structure, which you can conduct, in which you have these substances, the target substance for which you want to fill the data gaps, and the different analogs. And then you fill in the data you have, the experimental data from the known material chemicals, and you can fill in the derived results for your target parts. So it starts off with a summary of your data gap filling, but you also want to know how structurally similar they are. So you also, if you would scroll down, you cannot do it here, see the physical chemical data, but also data on kinetics, molecular profiling, and any other data that supports the read across to the related endpoint. So after doing this matrix, you can scroll, you have this whole summary, and you go to step 6 and evaluate the analog. So also to evaluate first the availability, what data is there, and what is the quality of the data. And with that, you have to make a justification if these analogs are justified to use this for read across. So that means that there has to be a consistency for each endpoint, but also across endpoints, they need to be similar. And also, it would help if they have, if you know the mode of action, if they have a similar mode of action as well. So these are all arguments to take along. And then you go to the next step. So you can have a look, assess the adequacy of the whole approach. So have a look into your chemical identity and your composition, your functional groups, common substructures, the PhysChem data, and then there's some other issues. You can look at the chemical reactivity, and the kinetics, bioactivity, mode of action, as I said already. And so on. So also there you can use in chemical and in vitro assays to really test how similar your material is. And then you start filling the data gaps. And this you need to document really closely. So also justifying it and pointing out any remaining uncertainties. I think that's it for now.
Thank you very much,
Martin.
Susan.
I see in the chat, I was looking for the already existing way to approach polyaromatic hydrocarbons. I struggle with pronouncing this altogether. Thank you for that. Thank
you very much, Susan. I guess now it's really the perfect time for looking into the regulatory. We're almost there actually with this last statements to the regulatory toxicology in practice. Over to James.
Yes, and that's a perfect transition, because this is the person that would actually do this kind of read across. So today I'll give you the perspective of how regulatory toxicologists actually work in industry. But this is not only applicable to industry, but also to toxicologists at ECHA also. So the toxicologist himself or herself has a wide range of actual tasks. So obviously the documents submitted to different authorities have to be compliant with legal requirements. These tests, which I'll go into in a few slides, are based on the global testing strategy, which is developed so that a certain document or test that is performed is applicable in as many as possible jurisdictions. This toxicologist also has got a lot of data analysis to do, as we've seen, looking for read across, for example, interpreting results. This all is prepared into a large dossier for each substance. Chemical safety assessments, occupational safety, occupational medicine can be part of the job. Looking into differences, into how actual these documents have to look like. For example, cosmetics or food contact materials have different regulations than performance materials. And yeah, I'll get into a few of those in the next few slides. So we're starting off. We have, as you know, the world is diverse, and as diverse as the world is, are obviously some regulatory requirements. So if you want to sell a substance somewhere, for example, in North America, you have different EPA, EFSA, depending on the category of substance you want to sell. You've got different regulatory hurdles, boundaries that you need to follow to register and sell your product there. In Europe, we know that we've got REACH, but also in Europe, there are different levels of regulatory compliances that have to be done. Asia also has different ones, so just an overview. And they vary in strictness. For example, cosmetics regulation can be stricter. One of the jobs I mentioned is the development of a global testing strategy, meaning we want to reduce the amount of animal tests performed in general. So you want to have a test that's applicable in as many of these countries as possible, so you don't have to test multiple times. So a job of a toxicologist would be to think about how does this test have to look like, that as many countries as possible accept this test. Or yeah, so it matches the data legal requirements. Yes, have we got any local particularities? And this leads to the development of the smart testing strategies. And of course, the toxicologist would be in contact with local country experts who know the local system even better, because nobody is an expert in every legal system. Just a short example of one of these regulations on how this data is submitted. So the data is collected, first judged and everything, but what does this data actually look like that is submitted? It's submitted in a dossier, which is based on the OHT, which is OECD harmonized templates. This is speaking for Europe. Many others have adopted this platform. But what actually is a dossier? So I just mentioned this. So on a very high level, it's a collection of information on one specific substance. So you'd have 100 substances with 100 dossiers. And they are organized in a way, just this is based on the submitting platform that can be used in some regions. For example, in Europe, you'd be using Euclid, developed by the ECHA. Just a short overview is that we have some basic information on the substance. You have information on who the applicant is, meaning the company registering under REACH, for example. Then you have some information on the identity of this substance, some physical chemical properties. So basically, and we go down to here to under 8 and 9, we see toxicological studies and ecotox profiles. So this is very standardized, which it has to be, because at the end, this is checked and it needs to be in a standardized format. So not if you have 10,000 substances, there are also 10,000 different kinds of dossier levels. And yeah, just the requirements for these OHT, these templates are listed. Some of them I've got here. So we've got templates, as we saw. If I go back to this slide, This was just for the physical and phys-chem properties of an active substance, for example, that is registered. Then this is a subgroup of this, and this is just a small excerpt of this. So we'd have a standardized template on how to document the boiling point, the density of the substance, vapor pressure, etc. And all of these, this is a template, basically how it should be structured. But these templates are based, again, on OECD test guidelines, which are also strict guidelines that have to be followed to fulfill these requirements, as I mentioned before, to, in this regulatory environment, fulfill all necessary requirements. These are adopted by different requirements, because if you think of every small country in the world that's maybe not part of the EU, they sometimes also use the EU requirements, because that would be too much effort, I guess. But yeah. So if we go back to how this dossier or a submission would look like, so this is part of the registration process, as I mentioned. For example, this would be the Euclid interface where where someone has registered 17 substances. These are in 15 dossiers. We can also register mixtures which have slightly other requirements compared to a single substance. And I didn't want to go too far into Euclid because it gets very complex very quickly. And just as an overview, there are manuals if someone is interested, and you can look into how Euclid is structured and how you can use it. And I have one number, so 1977 is associated with Euclid. This application manual, this is, for example, supplied by the EFSA, but 1977 isn't a year, it's the number of pages in this manual. So feel free, I've included the link if you just want to have a look. So it's a very complex task of fully understanding the submission, but it's very important. Yeah. For development of global testing strategies, as I mentioned, we have a substance. When we then maybe have the requirement in this, if I go back to here, we have under 0.8, we would have a list of toxicological studies that have to be performed, and one of them may be the acute oral tox profile is missing for this substance for some reason. Then going back to these templates, there would need to be an assessment. So do we have data on acute oral toxicity for the substance? Then a lot of questions have to be answered. Is the substance pure? Are there studies out there in publications? Have other companies registered this substance? And this is all job of the toxicologist, basically. Then if we don't find sufficient evidence, then a study has to be designed. This would include some dose selection for these studies, including study monitoring, meaning the study is ongoing and has to be monitored, by the way. And all of this can include a broad test spectrum from in vitro over in vivo tests in mutagenicity and organ toxicity, etc. So it's very diverse field of substances. Yeah, part of all of this is, of course, again, the chemical safety assessment, including critical evaluation of studies and literature for the submission I mentioned earlier on, because not all published literature can be used for this, since certain criteria are not fulfilled or are fulfilled, and this has to be evaluated. Yeah, I mentioned parts of these beforehand. So you also have risk assessment for workers and consumers. You evaluate risk mitigation measures, for example, when using products. But on this perspective, since I was talking on the Euclid registration, I was talking on one single chemical substance that is registered. Yeah, and still, if the data is sufficient or if additional data is required, has to be decided by the regulatory toxicologist. Again, I measured that different applications of substances have different rules. So basically, if you have cosmetics, food contact, biocides, toys or in pharma, you'd have a different kind of regulation that applies to this substance. Yeah. This also has to be assessed, and yeah, some examples for food contact is, again, different regulation across this different jurisdictions, which is based on local law. Yeah, the required data depends also on this, coming back to the testing strategy that the regulator has to plan out, and also assessing if there is exposure from multiple sources. Just a final short overview, what also can be part of a toxicologist in a regulatory context is emergency responsive. Some of us may remember something like the East Palestine, Ohio train crash. If there are incidents in the environment, for example, then the regulatory toxicologist would be there to have to assess how did this affect the environment, how does it affect humans, and basically there are some on-call duties that can be involved with this. And that was the quick overview of regulatory toxicologists, I guess.
So we are already coming to an end of our first session of this series of safety-related issues, and we saw that we actually got a kind of an introduction into the safety dimension with these important two aspects of hazard estimation and exposure assessment, of course. And we really started from the very beginning, even mentioning Paracelsus law, hazard times exposure is risk, and this is inverse to safety. And safety is what we talk about within SSbD. What did we see after this insight, and to do really taking it from the very beginning? We looked into material safety data sheets and the pieces and relevant and essential pieces of information there. We also did this in an interactive session using Mural on 3 different nice examples. We, by that way, also got some first insight already into hazard banding and to the age phrases. There are tools out there, already a little bit a teaser for one of the next training sessions on safety, when we are going to be applying and looking further into a hazard banding tool. Susan then gave us some insight into the SIS database, what we find there and how we can employ it. Grouping and read across following this OECD test guide, OECD guideline, I should say. And finally, then James gave an insight into the diversity of the regulatory toxicological fields there in the current practice. Today, it was the basic session, and there are more to come. I would like to ask now whether there are any remaining questions or comments, something that we should still add from the topics that we covered. Have we been clear enough? No immediate questions come up. Of course, we are always can be contacted, the Planets Project, via info@planetproject.eu. We are going to be not stopping here. We are still having another session in a week's time. And then we are going to be looking into intermediate level, tier 2 safety assessment, and here in silico approaches for hazard assessment, but also for exposure assessment by in silico tools will be the topic. So stay tuned with us. After the summer break, we are going then to continue with tier 3 level assessment methodologies and dive then into the diversity of all these different technologies. Thanks to everybody who participated actively to this session. Thank you to Josephine and Cecile from CA. Thanks to James from BASF. Thanks to Susan, TNO. Thanks to Beatriz, BNN. And thanks to my team already in advance for helping with the workup of all that.